Hi there. So in the Macmillan Lab, we're interested in using photoredox as a versatile platform to engage in bioconjugation reactions because of its feasibility to generate radicals under extremely mild biocompatible conditions. And in particular, we're interested in tyrosine bioconjugation for a variety of reasons. For one thing, no.
Take 3, okay. Our lab is a biophysics lab where we use physical technique to study the complex and dynamical biological system, where we develop a bunch of techniques for us to follow the highly dynamic biological system and then push it to any place we want.
I'm in Andy Bocarsley's group, and we work on CO2 reduction for making interesting products out of CO2. So some of the work that I've been doing is with these manganese electrocatalysts, turning CO2 into CO. And a lot of the work on this poster is about creating these catalysts for turning CO2 into CO.
In the Mo Lab, we're very interested in studying bacterial natural products. We like to study these because natural products and bacteria are very easily tractable genetically. They're all in genes that are directly next to each other, encoded directly in the genome. So we can study new chemistry by studying radical SAM enzymes, and we can study new biology by figuring out, after we find the chemistry, what these new natural products will do.
So we're studying this gadolinium antimony tellurium system in which we see structural distortions that change in accordance with how much antimony and tellurium are in the system. And we're trying to use these distortions as a way to engineer the electronic structure of the material to access unique electronic states.
These motifs have biological important function in the activity of enzyme. This is stressful.
30 seconds is quick. In the future, we want to identify readers of the mark, and hopefully this will help us elucidate the function of the modification.
Staph aureus utilizes short macrocyclic peptides to communicate information about cell density and coordinate group behavior. The Muir group was able to reconstitute this biochemical system utilizing lipid nanodiscs, and it was able to show how binding of the signaling molecule affects changes, introduces information. Furthermore, we were able to validate the full biosynthetic of the mechanism of these pathways, which allows us to validate targets for therapeutic development.
Can I do again? Yeah. Sorry. If you consider all the possible combination of amino acid in a protein, what happens to those that are never sampled by nature during evolution?
I'm just trying to figure out which points I want to hit. And it's reasonably tolerant across alpha carbon substitution and arine substitution, and ended with an and, but...
There are these materials called topological semimetals. We're looking at 2 of them, zirconium silicon sulfide and zirconium silicon selenide, and we're looking at how they respond to light on really short timescales. And to do that, we use a method called, was that 30 seconds? Jesus.
We entered into a collaboration with the Macmillan group in which we could potentially access remote stereocenter racemization in coupling with keto reduction with ketoreductase enzymes. And we were able to get it to work with a very nice scope.
In this reaction, I'm trying to do an Ullmann-Goldberg coupling, which is usually limited in its scope. But by overcoming essentially what's known as the copper oxidative addition problem, I can activate a wider variety of substrates using a novel light-mediated mechanism. I don't know if those are real words, but I'll just go with it, I guess.